I'm going to be discussing the problem longest increasing subsequence. The problem statement says that given an integer array nums, return the length of the longest strictly increasing subsequence. So I actually took out the kind of approach that I would follow while solving this problem. First I was traverse to the array, take the first element into consideration and see if the next element is greater. Then follow along with a for loop and then keep going to the next element. If the sequence breaks with the next number smaller than the current number, we come out of the for loop. Then we need to maintain a variable count for keeping the track of the maximum counted sequence visited. So this was the approach that I thought I would actually take, and while I was looking at the YouTube video, there were two approach which I got to know about solving this problem. First one is the recursive. The recursive problem statement says that a subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. The recursive LIS solution works by exploring all the possible subsequences through a decision at each index. Either take the current element if it's greater than the previously selected one, or skip it. Each recursive call moves forward in the array, and the length of the longest subsequence is calculated by taking the maximum of these two choices. To avoid recomputation, the solution memoizes results of each state defined by I, previous index. This transforms an exponential brute force search into a polynomial time solution. The dynamic programming. The problem statement says that we need to start from the last index and work our way backward. Then LIS is starting at index 3, and then how do we get the LIS of 2, which is just one shifted to the left. So we are only allowed to do above if the value of nums at 2 is less than nums at 3, and then we can go on creating a subsequence like this. And then we are actually using dp to compute for each index I the length of the longest increasing subsequence that starts at I. We create an array LIS where each position initially has value 1, because the smallest increasing subsequence starting at any element is the element itself. We iterate backwards through the array so that when we are at index I, all future indices j is greater than I have already computed their best LIS lengths. And then for each pair I, j, if nums at I is less than nums at j, then we can extend the subsequence starting at j by placing nums at I before it, and so we update the LIS of I is equal to max of LIS of I, 1 plus LIS of j. After filling the dp table, the answer is simply max. And then since the longest subsequence may start anywhere in the array. So the pattern of problem observed while solving this problem are right to left dynamic programming. Second is dp on subsequences, where skip is allowed, compare I with future j. Third is to loop dp with future dependency. Fourth is state transition using pairwise comparison. Fifth is building dp of I from dp of j, where j is greater than I. Sixth is transforming recursion to memoization to bottom up dp. Seventh is maximum optimal subsequence construction pattern. And then eighth is using dp to optimize exponential brute force. Ninth one is subproblem decomposition, where we need to solve it from end to start. And then the last one is binary search optimization of dp, where patience sorting a idea concept is used.